Hello everyone, so welcome to the another home lab chemistry experiments in which we will try to make another biodegradable polymeric plastic using corn starch, vinegar and glycerine. In my previous video I have shown you how you can make a polymeric material using glycerine and citric acid, but right now this time we are going to use corn starch, vinegar and glycerine. Using this material, there are already have published material is already in the literature. So I will list these paper, and at the end you can review those papers. So before starting our reactions, we'll talk about some more corn starch. What is corn starch, and what is the acetic acid, and what is the glycerine, and how they affect in what type of the role they use in these reactions. So we'll talk about this reaction first, and then we'll start our reactions. So let's understand the reaction first. To prepare biodegradable polymeric plastic material using estification reaction, basically we are using acetic acid and some of the alcohol starch alcohol got esterified. That is why I just written estification reaction. And so here the ingredients are, or starting materials are, like a glycerol or glycerine. This serve as a plasticizer. Plasticizer means like a glue, so it combine all the starch into flexible material. Then acetic acid, which is we are using in the form of vinegar, and very low acidity, 5% only. And starch is a polymeric, this is basically starch is a glucose molecules which are linked in several chains, and we have to mix these together and then heat. After that they will cross link to each other, and then got the flexible dense polymeric bioplastic material. So if you'll see, so what usually happen, probably the primary alcohol got esterified with the help of acetate ion, and then the glycerol, which bind with the hydroxyl group of the starch, and it combine the other molecules of the starch by hydrogen bonding. In this way the whole starch, which is in the amorphous powder, that become a polymeric flexible material. So this is the one thing. And then let's talk about the glycerol and each starting material one by one. So glycerol, or this is common name is glycerine. This is also called glycol alcohol or sugar alcohol. So this is the structure here, carbon 3, hydrogen 8 and oxygen 3. So this is the structure like a CS2OH, CHOH, CS2OH, and you can write like this one. And this IUPAC name is propane 1,2,3 triol. So glycerine is a simple polyol compound, means alcohol. You can see there are some 3 alcohols are grouped, 2 primary alcohols, 1 secondary alcohol. And this is a viscous liquid, sweet in taste and non-toxic. Glycerine refers to commercial grade and irrespective of their purity. Glycerol is the term used for the pure compound propane 1,2,3 triol, and glycerine contains slightly more calories per gram than sugar, and it is a sweet approximately 60 to 70% as sugar. So glycerine occur naturally in fermented food and beverages. So why we are using in this reaction? Because it serves as a plasticizer. Plasticizer means glycerine make the bioplastic more flexible because it bind all the alcohols with the hydrogen bonding. So this is the about the properties and of the glycerol. Next our reagents is the acetic acid or vinegar. So we are using a white vinegar, and white vinegar have acetic acid. So acetic acid formula is CS3COOH, or you can write in this form also. So molar mass is 60.05 gram per mole and density is 1.05 gram per centimeter cube. White vinegar we are using, so which have the white 5% acidity. 5% acidity means 5 gram acetic acid in 100 ml aqueous solution. And so calculation, if you will see, if we will make it in 1 liter, so it will become 50 gram per liter. And so 50 gram acetic acid in 1 liter divided by molar mass, then we can find out the molarity of the solution, which is 5% acidity. So 0.833 is the molarity of the acetic acid we are going to use it. So our third reagent is the starch, and there are many sorts of starch like a corn starch, potato starch, rice starch, cassava starch, and tapioca starch. So they have different weight based on the molecular weight. They are in a small or big chains. So let's talk about the first is corn starch, which we are going to use. So corn starch or maize starch, or it is also called corn flour. So corn starch or starch is an organic polymer. And what type of polymer? Starch is a polysaccharide composing of alpha D glucose monomers joined in 1 alpha 1 4 linkage glycosidic bonds. The basic chemical formula of starch is C6H10O5 small n. So small n would be thousands and even number more. So it means all the glucose molecules are connected together. So simplest form of starch is the linear amylose, and amylopectin is the branch form. So here I have shown the structure of amylose, which is the simple linear form. So if you will count here how we name the number of these ones, so basically we start from number 1 here, number 1, number 2 carbon, number 3 carbon, number 4 carbon. And same thing is here, number 1 carbon, number 2 carbon, number 3 carbon, number 4 carbon, number 5, number 6, like this one. So 5 and 6. So this bond, that is why it's called 1 and 4 glycosidic bond, and the N would be 300 to 600, or even other starch it will be more. So this linear form of the polymer of glucose, which is called amylose, so they will be like this kind of in the circle, spiral form and linear. But you can see there are many OH, primary OH are free, so probably they bind with the another glucose, and then they form a branch type of the structure. So this is the branch type of structure, and then if you they joint here the other branch with the alpha 1,6 glycosidic bond, and if you number it, so 1 2 3 4 5 6, and then here is 1 2 3 4 5 6. So that is why this linkage is called 1,6 glycosidic bond. And here you can see in amylopectin, usually amylose are connected with the other branch molecules. So the whole corn starch or potato starch, or they are all very complex and with the branch one. So that is why we use our reagents like acetic acid. And let's go once again on our reaction. So once we use acetic acid and glycerol, so they go in between, and then they make the hydrogen bonding, and then acetate of the ester bond. They form ester bond with the acetate ion, and then make the whole material, rather than powder, it will be like a flexible biomaterial. Okay, so for the required material for this experiment, The very important thing, first we need goggles, and if you do not have any goggle, you can use any your sunglasses. Then I'm going to use this corn starch. Here is glycerine vinegar, which is have 5% acidity, which is distilled vinegar. And then color is optional, it's not compulsory. And then I'm going to use these seeds in my plastic material, so if we will throw, hopefully they can grow some seed flower plants. And then here I have some pots and pans, bowls, a spoon, then balance, aluminum foil, and I need a small oven, or if you have a big oven you can use that one. And then we have some pencil, pen and scissor. So let's start now our experiment. Okay, so let's start our experiment, and before that first we need to wear goggles. And I said if you don't have this one, you can use your goggles, this one. Okay, so let's start now. Okay, so first we will weigh our glycerine and make sure this weighing is we have to tear it first. So here you can see this plastic have 40 ml, 80 ml, 120 ml. So, and then after adding this I have to tear it. So now it's teared, and then add glycerine first. Let's open this one so that we can add more. And then I'm adding approximately I think it's around 40 ml, 40 grams. 40 grams. You can see around 40 grams and almost 40 ml also. You can see this is 40 ml and yes, almost ready to 40 grams. Okay, so I measure once again and I find it's around 45 gram and approximately 40 ml. So here you can see it's little over than 40, so basically it's around 45 gram. And then I'm going to add this white vinegar. The white vinegar will have very weird smell, so be careful once you work with this one. And then I'm going to add this same, almost volume wise same. Yes, so same volume I added in both of them. And so here you can see it shows around 80 ml. And what is the value here? It's again 45 probably, because it is showing around 90 right now, 90 grams. So gram wise it's also surprising. I mean, my balance would be little different, then it's not very accurate, but anyway. Okay, so I revisited on these numbers and then came out that we have approximately 50 gram of distilled vinegar and then 40 ml. So volume wise I kept the same, but the values on the gram quantity is different, 45 gram and here 50 gram. So now next thing is to transfer this liquid into our just mix these first and then pour everything in this pan. We can also take maybe I will add little bit water, not too much. That's it, just to rinse it. So water is okay because it is all ingredients are water soluble. Next we will add corn starch. Okay, next is to weigh our corn starch. So I'm using this big plastic bowl, and then we have to tare it. Always make sure tare to 0, even if you are using in the lab. And then this is the corn starch. So let's I'm going to weigh some extra first. We'll see how much we are going to use it. So right now we have approximately 40 grams. Let's take more. A little bit more. Okay, so it's around 50 gram right now. You can see. So I weigh approximately 50 gram cornstarch I have right now. Then we will add in this mixture slowly. But before that I need a plate. And I will use, if you do not have plate, that's fine. I'm going to use aluminum foil and just place it here like this. So we will once we will be ready, we will put our sample here. And also I'm going to apply a little bit Vaseline so that it don't stuck my product here. I can use some oil also, but let's use the Vaseline. I think this will be much better. So just hand apply. This plate is ready now. Now start heating. Okay, so now we are all ready. Here is our glycerol and vinegar and cornstarch, and here is our food color. But this food color is optional, 100% optional. But I want to add some food color, so I will add 1 drop or 2 drop of this red color. I'm going to add red color here. 1 more drop, and that's it. Okay, I hope this will. So here you can see this mixture is red color. Now before starting heating, I have to start the exhaust, and then heating is start. Now you can see once it be start warming, make sure you have to keep mixing, and then probably we have to add slowly the cornstarch in this mixture one by one. Maybe I think I will stop the heating first, and let's break the lumps. All lumps we have to break it first. So add slowly. I'm planning, I will see how much I can add here. Let's add all of this. So almost everything came out. Maybe I can a little bit water. So add little bit water and then pour all the starch here. Okay, now you can see I was keep mixing and then it's very smooth slurry. So now it start heating. So make sure don't left it, and the time if we will start, see how much time we are saying, 3:05, and then we'll keep mixing. I will see how long I am going to mix it, and heating is on. I'm thinking if we have a non-stick pan, that might be easier to remove water quickly, because might be it will take some time. Okay, so we'll show you after some time how long I'm going to heat. Right now it's still 1. Let's keep focusing on that time. So it's already 1 minute is completed. Just keep mixing, don't leave it. So here you can see within 1 minute, oh my goodness, it start making a semi-solid. So I'm going to slow heats on everything is low heating. Now you have to mix it. So within a 2 minute, you can see within a 2 minute it will become a semi-solid mixture. So keep mixing. So here you can see within a 2 minute it become a semi-solid. So now you have to remove it from here. I think I will remove it from here. I'm doing a very slow mixing. So within a 3 minute, and start the heating off. So 3 minutes. So total time I heated around 3 minutes. And now we'll drop this in our plate. दूर से रखो जरा, बिल्कुल घुस जाती तो. So it was 3 minutes and heating, and after 3 minutes you can see it become a semi-solid. So now it's time to place on this plate. So now I'm going to add these flower seeds at this time here. This is done. I have some lavender one also. I will add those as well. Okay. Now I can touch with my hand. It's a little okay. So you can see it's look like a Play-Doh or rubber. Now we will place it here. In this okay, so you can hand press it basically like this. We can make a bowl also if do not have any plate. or if you have a rolling pin, you can use a rolling pin to make it everywhere straight. Okay, now you can see it's very easy to remove from this bowl also. It's I'm just scraping with my hand, it's coming in my, so I place it wherever it needed. So I just spread it all with the hand, but if you have any heavy item, you can make it smooth, or if you can use this bowl also. I think I will use my hand, it's much better. So almost ready to go in the oven because we have to dry it now. Okay, so ready to go oven. Okay, so now I'm going to put this in our small oven, which is a minimum 65 degrees Celsius or 150 degree. So let's put it in the bake and then start for 45 minutes, and then slowly we will heat and come back after some time that to see the drying process. And now for its cleaning, it's very easy. You can just soak everything in water, and maybe you can add some soap. I'm just adding some soap, and it will be easy to clean. So here you can see heating is done. So after 45 minutes, I was heating at 65 degrees Celsius or 150 Fahrenheit. Now I have to increase the heat because when I check it is soggy. So, and I don't want to burn my seeds, so just want to be careful. So let's increase the heat to 225 or 120 degrees Celsius, and the bake mode again, and then so here it is 45 minutes again, 15, no, total 30 minutes. It was actually 30 minutes. So this was not 45 minutes, this is 30 minutes. So we'll come back after 30 minutes again, and now I'm heating at 250 degree Fahrenheit or 120 degree Celsius for again 30 minutes. Okay, so after heating 30 minutes at 120 degrees Celsius, just open it and let's check. It's a little warm. So here you can see there are so many cracks, or it means starch is too much. So use this paper or cloth and let it cool down at room temperature. So now it's time to cool to room temperature, and then we'll see after some time. Okay, so here you can see after 1.5 hours, this is very cold at room temperature, and now we will do our product observation. What are the observation we are getting from this, and then what test we will do, and what type of analysis to see what are the qualities of this product. So let's start one by one. So now you can see the first observation is look at the surface of this product, and it has so many cracks on the surface. It means that starch will be too much, so that is why it did not cross polymerize. So next thing I don't know if it will come in the one piece or not. Oh wow, it is coming in a one piece. which is nice. But even then I don't want to take a risk, so first make sure it is a 0 here, and then I will place my plate here. And then after that, what is the reading here? It's around exactly 250. Okay, so now you can see here it is exactly 250 gram total, so 250 gram total. Now we'll try to remove this from the surface because we put a Vaseline, so it is coming, I think, very nicely. This part. Oh wow, look at this, so nice. Okay, let's keep this one because it has so many cracks, and it's and let's weigh my empty plate first. So this is 101 to almost 125 gram. So 125 gram. It means if I will minus plate, so basically 125 gram. Yes, 125 gram product came. So now you can see this is much better, but still this side is very nice and sticky. It is still sticky, but here you can see this is a gap. It's a broke in. And also there are so many gaps. It means there was really too much corn. And next, how we can use it? I mean, probably I can place my fruits here. So this will serve as a fruit. Oops, this is a bigger one. Let's put it inside. So this could be like a food plate. It's not very comfortable, but it's okay. Next thing, analysis, we can do it like to see if we can break it, how it will easily break it, because we know that this is, if I will press it, it is easily, you can see from here. Let's make it so it's easily breakable. So there was not much cross linking, that is why it's breaking easily. Next we will do the water test, how good in the water. So next experiment we will do in the water test. So just take one glass and then add some water, and then I will use this portion because there are less seeds here. Yes, I think I will use this portion to break it, and pour in this in water, and we'll see after some time how it will easy to dissolve, or how long it will take. So this after 3 hours I soaked in the water, and let's see how is it working. So you can see it's going slowly, but still it is very thick. So maybe I will leave it until we'll see tomorrow. So here you can see after 24 hours. Let's check how it is dissolving in the water. So you can see it's still, oops, it's almost gone. I cannot hold in my hand. So it's all dissolving, I mean all breaking up easily within 24 hours. So next thing, how I'm going to throw this one. This was the another half part which we made like a cup. So if it will be thin, probably we can mold it in a better way. The last part of this one is how to decompose this one. So rather than throwing in the waste, I would like to put in my flower pot, and then maybe some more seeds, and want to see if this seeds will grow or not. So Let's fill some more soil on this one. And then add some water. Water in this one. And then now you will ask the question that if they will grow or not. So I will write a result in the comment box after some time, maybe 15 days or after 1 month, to see if they are growing or not. So this was the one experiment, and now after that we will write our conclusion and result analysis. Okay, so now you can see that we have made a very nice thick plastic. I mean, still we need a lot of optimization in that reaction. I think I used too much starch, that is why it was cracked on the surface. So I have collected all my data, and then we'll talk about post lab data analysis and results and conclusion. So we'll see what we can do improve in the future. And I think we need to change the amount of glycerine and amount of acetic acid, and maybe cornstarch, certainly low amount, and then study their properties once again. So if you are trying this experiments, I will suggest not to use 50 gram, just reduce 25 or 30 gram and do your experiment once again. And I use this seeds, so when I throw, hopefully they will grow the plant. So our biodegradable plastic will also help to grow some plants. So in the post-lab analysis and results and conclusion, here you can see glycerine we used, which was 99.5%. My weighing was around 45 gram or 40 ml, but I think I'm confused about this 40 ml, because when I use this gram with the density, I should get 35 or less. So might be cup is not very well, but anyway, molecular formula is 92.05 gram and density is this 1.261 gram. So 45 gram would, once will be divided with molar mass, it will become around 0.49 moles. And if we further do more analysis by 99.5%, then it will be 0.488. So these two numbers are almost same. And then let's talk about the acetic acid. So acetic acid, we take the 5% vinegar. So 5% when we weigh, it was around 50 gram or 40 ml. So here I use this 40 ml. So 40 ml basically, and the molarity of the 0.5% vinegar is 0.833, which I have seen earlier in the introductory part. And then once we divide this one, probably it will be very low, 0.033 moles of acetic acid compared to glycerine. And then cornstarch I use 50 gram. I think this was too much. And when I weigh my plastic, it was come around 125, but it was still soggy, and might be it have more water. So what is the conclusion? Conclusion is product has the crack on the top of the surface, bottom surface was smooth and shiny, and product was flexible but thick. It has some strength but not too much. Product was easily water degradable. After, you can see after 24 hours it was already gone. And in the future work, changing the amount of the reagents and lowering the amount of the starch would give better strength of the polymer. And heating time and temperature also need to be optimized. So these are my post lab data analysis, and then you can also read the further paper for these as a reference.